Okay, today we're going to look at how we can build a simulation model to simulate so-called waiting line behavior. So there's a DMV who opens between 8 a.m. and 12 p.m. on Saturdays. There's only one window, so that means only one customer can be served at a time during Saturdays. So based on historical data, the DMV believes that the inter-arrival time between customers is normally distributed with a mean of 15 minutes and a standard deviation of 4 minutes. The DMV also believes that each customer takes between 5 and 20 minutes to serve, or more specifically, the customer service time is uniformly distributed between 5 and 20 minutes. And the DMV estimates that there are 30 customers on every Saturday. With that, the DMV is interested in evaluating two numbers. First, how long does a customer wait on average before being served? And second, how much time does a customer spend in the DMV in total? That means the time between a customer arrives and the time the customer finishes his or her service. Okay, so let's start the simulation. I have the time parameters over here. We know there are 30 customers on a Saturday. So how do we start the simulation? Well, I'm going to start the simulation in this way. I'm going to simulate the behavior of every customer. There are 30, so let me index the customers all the way from 1, 2, 3, all the way to 30. Okay, so these are the index of the customers I'm going to simulate. When you start to simulate, you need to think about what's next, or the so-called sequence of events that will help you to think about what kind of columns you need to generate. So when the customer arrives, what happens? Well, first, I figure that I need to record the time a customer arrives. Okay, so let me record something called arrival time. But what do I know about arrival time? Well, I really don't know about arrival time, but I know something called interarrival time. Interarrival time is a time between two customer arrivals. So interarrival time will allow me to generate the arrival time. So I figure that before arrival time, I actually need something called interarrival time. Okay, and interarrival time is random. Okay, it's normally distributed. So that means to generate interarrival time, I need a random variable because interarrival time is random. Okay, so that's why I generate these columns. Okay, and then what's next? After a customer arrives, what is the next event I need to record? Well, the next event is simply the time the customer starts to being served. So let me record something called service start time. Okay, so this is the time the customer starts to be served. Okay, and then once the customer being served, what will happen next? Well, the customer will be finished being served. Okay, so let me record something called service end time. And how do I know the service end time? Well, I know the service time is random following the certain distribution, so that means it's something I need to simulate. Service time is random. I need to simulate that. So to simulate that, that means I need to generate something called service time. Okay? So I decide to insert another column in between called service time. With the service time and service start time, I can generate the service end time. And in order to generate service time, I realize, okay, it's random, so I need a random number, so I'm going to put a rand over here. After a customer being served, what's next? Well, there's no next thing. Well, the customer leaves and that's it. And at that point, we can start to calculate the metrics we concerned about. First one, the waiting time. Okay, so I can calculate the waiting time. Second, the total amount of time the customer spent in this DMV. Okay, so I'm going to put it here. It's actually not bank. Okay, let me change it, DMV. Okay, so at this point, I have the columns I need to to perform simulation. Okay, now let's start the simulation. Rand is simply a random number. We are supposed to put rand over here, but just to make sure we all have the same number, let me type in 0.5. Okay, arbitrarily pick a number. I pick 0.5. Okay, just for illustration. With that, what is the inter-arrival time? Well, this is normally distributed with these parameters. So it's normally distributed, so we use the function called norm.inv. The first input is probability, which is the random number. Okay, mean is over here. I'm going to put the $sign to fix the reference. The next input is standard deviation over here, putting the $sign to fix the reference. Okay, so that's the inter-arrival time corresponding to this random number. Well, that means the first customer is going to arrive 15 minutes after the DMV opens. Okay, so that means the arrival time is just inter-arrival time. Here, arrival time 15 means 15 minutes after it opens. Okay, you can try to record it as like 8:15 if you will, but it will be fine if I just record it in this way too. I know it means 15 minutes after it opens. Okay, so for the first customer, when this customer arrives, there's no one in the DMV. So supposedly this customer can start his or her service immediately. So that means the service start time is going to be the same as the arrival time because there's no one there. So the customer can be served immediately. Okay, next we need to determine the service time. Okay, so that's why we have another random number here. Let me use, let's say 0.6 just for now. Service time is uniformly distributed. So we use the formula for uniform distribution, which is the mean, okay, fix the reference, plus the random number times the difference between max and mean. So max minus mean, okay, and putting $sign to fix the reference. Okay, so we find the corresponding service time, 14 minutes. So, and then service end time. So if this customer is going to be start being served at time 15 and it takes 14 minutes to serve, naturally that means this customer will be finished at time 15 plus 14, so 29. Okay, so this is a time when that first customer is going to leave. And how much time does the customer wait in line? So this is the time the customers wait. This is the time between the customer arrives and the time the service starts. So this is simply the service start time minus the arrival time. It's 0 naturally. Total time in DMV, that is simply the time this person leaves minus the time this person arrives. So it's this. Usually the formula for the first customer is slightly different from what happens for second customer or second period or second whatever onwards. So let's go over the second customer to see if anything is changed. Okay, rand, okay, it's just random number, so let me pick 0.6 just as a placeholder. Okay, with that inter-arrival time, are we going to use the same formula? Well, yes, there is still the same distribution, so I can just drag it down, okay, to copy the formula. What about arrival time? Well, is it still just the inter-arrival time? Well, actually, no. So the actual arrival time for the second customer will be this amount of time after the arrival of the first customer, of the previous customer. So it will be this number plus the inter-arrival time. Okay, what about service start time? Okay, service start time, the first customer is simply the arrival time. What about second customer onward? Well, not necessarily. The customer's service start time may not be just the arrival time, because it's possible that when this second customer arrives, the first customer is still under service, which is not the case in this example, but that can happen. So what you should do is this. So the service start time is the max, which means the larger of arrival time and service end time. Okay, so I leave it to you to think about why. So basically, if service end time is larger than arrival time, which is not the case here. Okay, if this number is larger than this number, that means this when the second customer arrives, the server is still helping the previous customer. So the second customer cannot start being served immediately. He or she needs to wait until the first customer leaves. Okay, so that's a formula. Okay, rent again. Let's pick, let's say 0.7 for example. Service time again. Okay, it's the same distribution, so I can copy the formula. What about service end time? Well, service end time is start time plus service time. That sounds right for a second customer too. So I'm going to drag it down. What about wait time? Well, wait time is defined as the difference between these two, and that's still right. So I can copy that to customer number 2. Likewise, total time in DMV is still defined as the difference between these two numbers. So I can copy that as well. Okay, so this is our second customer, and if you ideally when you move on to the next customer, you want to check again if all the equations are correct from the second customer. Our third or fourth customer using the same equations as in for second customer. Well, let me tell you, yes, that's the case. And now I'm going to change those random number back to R&D. So now I have a dynamic. Okay, I have a dynamic simulation. Okay, these are just rand. Okay, and now I can copy the formula, double click here, or you can drag it down. Okay, now I have the simulation for all 30 customers. Okay, that's great. But in the end, remember what I tried to record is the average wait time and the average total time in DMV. Okay, so I'm going to put the average of these two columns over here. Okay, average is average. Okay, likewise, average of this column. All right. Okay, so you will have different numbers than mine. Okay, that's okay. It's normal. Okay, let me highlight these two cells just to remind myself these are the key metrics I want to record. Next, I need to perform 20 simulation runs. Okay, so these are the metrics, the average wait time and average time in DMV out of one simulation run. I need to generate 20 simulation runs. This is where you need to use data table. Okay, so let's do this. Okay, here I need to create one all the way to 20. So just to represent 20 runs of a simulation. And in the end, I need to record both of this for every simulation run. How do I do that? This is how you do it. Over here, I do equal to this cell, comma. Over here, I do equal to this cell. Okay, what is that? Okay, just to remind myself, this is a waiting time. Average waiting time out of a simulation run. And this is total time in DMV. Okay, actually it's still average. Okay, every total time in DMV. Okay, so this is the average time every wait time, every total time in DMV out of this simulation run. And now I want Excel to store those two values for all the 20 simulation runs over here. How do I do that? Okay, now select this whole area. You need to select the area exactly the same way as I do. And now go to data, what if analysis, data table. Okay, here is a magic. Here in column input cell, please click on any empty cell that doesn't do anything in the spreadsheet. Let's say this one. Okay, and click on OK. That's it. So you have 20 simulation runs. For each simulation run, Excel also return the every wait time, every total time in DMV back over here. Okay, with that, I can calculate the average of those two metrics out of the 20 simulation runs. Okay, so it's just average. Likewise, over here. Okay, so that's it. These are the two numbers eventually I like to obtain. Finally, I want to spend some time to explain what happens in data table. Okay, originally I was right here and I said, well, go to data table and click on any empty cell that doesn't do anything. Okay, for example, like this one. Okay, so what happens here is Excel will run 20 simulation runs, 1 through 20. For each simulation run, let's say the first simulation run, it will take this number over here, which is 1. It will take this number, plug it into this cell, run the simulation, and copy the resulting numbers over here to over here. Then it will run the second round of simulation. In this second run, it will put this number over here, run the simulation, then copy these two numbers over here. Next, it moves on to the third run. It will put this number over here, run the simulation, and then copy the resulting two numbers over here. Okay, you probably see the pattern. This is how data table works. Here you go again. That's the result.